Okay, so let's take a look at number 3. In number 3, it says two boats start a race and race together across a 60-kilometer wide lake and back. The first thing I might do is try to get a picture of that, because when you have two objects moving in the same reference frame, that can get a little confusing. So let's diagram that out. Let's say this represents the lake that we know is 60 kilometers wide across. And we have two boats. Boat A and boat B. The question goes on to say boat A starts across the lake at 60 kilometers per hour and returns at 60 kilometers per hour. Boat B goes across at 30 kilometers per hour, and its crew, realizing how far it is getting, realizes how far behind it's getting, returns at 90 kilometers per hour. If the turnaround times are negligible and the boat that completes the round trip first wins, which boat wins and by how much? Or is it a tie? B, what is the average velocity of the winning boat? Okay, so what you do now is you list information, and you can list information in listing, make a list of variables and the numbers that they stand for. You can list information on pictures and diagrams. Whatever helps you organize the problem is what you want to do. So I'm going to go ahead and list stuff on the actual picture this time. It tells us that the return trip out there, which I'll call V1, 60 kilometers per hour. Okay, and for V2, or for V1 of the blue boat, of the boat B, it's at 30 kilometers per hour, so it's half the speed. Then on the return trip, we can call that, I guess, V2. Boat A returns at 60 kilometers per hour, and boat B returns at 90 kilometers per hour. Okay, so how do we figure out how much, how an object, or in this case a boat or a person, how do we figure out who wins a race? Well, it turns out the winner of a race, of course, is the one who completes it in the smallest amount of time, the shortest time. So ultimately, we have to solve for time, total time for both boats. Okay, so now is where we start to organize some of the information. So we've got information on the trip across, and then information about the return trip. By information, I'm talking about the data we're given in the problem and calculations we need to perform. And then lastly, total. Okay, so the trip across, we have D1, that would be the distance across, is 60 kilometers. Okay, it's the distance that boat A goes across the lake. Boat A goes across at 60 kilometers per hour. We don't know how long it takes. So we're going to use the following equation. V1 equals D1 over T1. Using the switcheroo, we can solve for T1, and T1 equals D1 over V1, which is 60 kilometers over 60 kilometers per hour. In other words, it takes 1 hour for boat A to get across. Okay, now, similarly, boat B, the distance across for boat B is also 60 kilometers, but boat B is moving at half the speed. Okay, we need to find the time it takes for boat B to get across. We're going to use the exact same equation. And again, we're going to use the switcheroo, solve for time. And it's 60 kilometers over 30 kilometers per hour. It takes boat B 2 hours to get across. Okay, now on the return trip, it takes, there's a 60 kilometer trip. Boat A goes at 60 kilometers per hour across, and we need to find that time. So using the same equation, T2 equals D2 over V2 would be 60 kilometers per hour, or 60 kilometers over 60 kilometers per hour. So it takes 1 hour for boat A to return. Then boat B also has a return distance of 60 kilometers, but is moving a third faster, 90 kilometers per hour. We need to find this time right here. So time 2 would equal the 60 kilometers divided by the 90 kilometers per hour, and it takes boat B 2/3 of an hour to get across. Okay, so now we look at total time. For boat A, total time of boat A, which I'll call TA, right, is T1 plus T2. That would be 1 plus 1, or 2 hours. Boat B, same idea. We're going to add the time there and the return trip back. This would be 2 plus the 0.67, or 2.67 hours. Now, 0.67 hours, 2/3 of an hour. If you looked at a clock, here's a clock. There's 0, 20 minutes, 40 minutes, 60 minutes. That means 20 minutes is a third of an hour. It means 40 minutes is 2/3 of an hour. So this turns out to be 2 hours and 40 minutes. Okay, so who wins the race? Well, boat A wins the race because it takes boat A 2 hours to get there, whereas it takes boat B 2 hours and 40 minutes. So boat A wins the race by 40 minutes. 40 minutes faster. Now in part B, we're looking for the average velocity of the winning boat. So anytime you see a variable with a bar over the top of it, that stands for average. And so average velocity would be change in position over change in time. Well, when the boat who is the winning boat, boat A, the change in position is going to be 0 because you're returning to the same spot you started with. Therefore, you have no change in position. Divided by the 2 hours means we have an average velocity of 0.